Welcome to Suck Our Next Gen Tech. All right, let's talk about AWS interviews. You know those foundational questions that always seem to pop up? Well, today we are going to crack them. We're going to build a complete cloud application from the ground up right here in our minds, piece by piece, so you can walk into that room feeling completely confident.
So, here's our game plan. We'll kick things off with a big picture, the global foundation. Then we'll dive into the real building blocks, compute and storage. After that, we'll see how to connect everything together, and finally, we'll cover the really fun stuff, making it all scalable and super secure.
Okay, first things first. Before we can build anything, we have to ask a really basic question. Where in the world is our application actually going to live? I mean, it's the cloud, but it's not actually floating in the sky, right? It has to exist somewhere physically. And that somewhere starts with what AWS calls a region. The easiest way to think about it is like a huge geographical area, a major city, let's say, where AWS has built a whole bunch of data centers. You've probably heard of them, like US East 1 in Virginia, or another one out in Frankfurt. These regions are completely separate from each other. And this is where it gets really clever. Inside each region, you have multiple availability zones, or AZs. So if the region is the city, think of an AZ as its own self-sufficient neighborhood. Each one has its own power, its own cooling, its own networking. They're completely isolated. The whole point is that if something goes wrong in one neighborhood, like a power outage, it doesn't affect the others. The city keeps running. It's a brilliant design for resilience. All right, so we've picked our city and we know about the neighborhoods. We have our plot of land. Now we need the actual building materials, right? We need the brains of the operation. That's our compute. And we need a place to put everything. That's our storage. Okay, get ready for this one, because you are almost guaranteed to be asked about it in an interview. It's a classic. They want to know if you really get one of the most important ideas in the cloud. How do you handle more users? How do you handle growth? And here's the difference. Vertical scaling, or scaling up, is like taking your one server and just making it bigger and more powerful. Think of it like giving one weightlifter more and more weight to lift. Eventually, they're going to tap out. Horizontal scaling, or scaling out, is the cloud way. Instead of making one server bigger, you just add more servers. You hire more weightlifters. You can add as many as you need to share the load, which makes your system way more flexible and resilient. So when it comes to compute, your two main choices are going to be EC2 and Lambda. Think of EC2 as your traditional virtual server. You get a whole machine, you can log into it, install whatever you want. It's perfect for something that needs to be running all the time, like a website. Lambda, on the other hand, is, well, it's different. It's serverless. You don't manage any servers at all. You just give it a little piece of code, and it only runs when something triggers it, like someone uploading a photo. It's perfect for quick, event-driven tasks. And what about storage? For that, we have S3 and EBS. S3 is basically a bottomless bucket for your files. You can throw anything in there, images, videos, backups, you name it, and it just scales infinitely. EBS is different. It's a high-performance hard drive that you attach directly to your EC2 server. It's what you use for your operating system and any data that needs super fast access. Okay, great. We've got our compute power and our storage, but right now they're just sitting there. The next step, and this is a huge one, is networking. We need to connect them all together in a way that's secure and lets us control exactly who can talk to what. And that starts with the VPC, the Virtual Private Cloud. This is your own private, isolated corner of the AWS cloud. It's like building your own digital fortress. You define the whole network, the IP addresses, everything. Nothing gets in or out unless you say so. Now, inside your fortress, you don't just leave everything in one big room. You create subnets. You have a public subnet, which can talk to the internet. This is where you put your web servers. And then you have a private subnet, which is completely cut off. This is where you hide the important stuff, like your databases. It's a fundamental security pattern. Only expose the absolute minimum. So how do you enforce these rules? Well, you've got two layers of security. First, at the server level, you have a security group. Think of it like a bouncer at the door of a single server. It's stateful, which is cool because if it lets someone in, it automatically knows to let them back out. Then for the whole neighborhood or subnet, you have a network ACL. This is more like a border patrol. It's stateless, so you have to create rules for traffic going in and for traffic coming out. Two layers of defense. Hey, just a quick pause. If you're getting some value out of this and things are starting to click, do me a favor and hit that subscribe button. We've got a lot more deep dives like this coming up, and it's the best way to stay in the loop. Thanks. All right, now for the really cool part.
We have all the pieces, the location, the servers, the storage, the networking. Now we're going to put it all together and design an application that's not just functional, but resilient. Something that can handle tons of users and won't fall over if one piece fails.
This right here is the classic go-to architecture for a highly available web app. Seriously, you'll see this pattern everywhere. Traffic comes in, a load balancer spreads it out across a fleet of EC2 servers. And those servers, they're in an auto-scaling group that spans multiple AZs. Even the database has a standby copy in another AZ. What does that mean? It means there is no single point of failure. If an entire data center goes down, your app just keeps on running. It's amazing. So the interviewer might follow up with something like this. That's a great design, but what happens if you suddenly get a massive spike in traffic, like you're on the front page of Reddit? They want to see if you understand elasticity, one of the superpowers of the cloud. And the answer is all about being proactive, not reactive. You don't want to get a pager alert at 3 a.m. You build the system to handle it automatically. Your auto-scaling group will see the CPU usage spike and just add more servers. The load balancer will immediately start sending traffic to them. And for an even bigger boost, you can use caching with services like CloudFront to serve content from locations closer to your users, so the request never even has to hit your servers in the first place. Okay, we've built something that's powerful and resilient, but none of that matters if it's not secure. So for our final section, let's talk about the most important piece of the puzzle, security. In AWS, security starts with IAM, Identity and Access Management. This is the heart of AWS security. It's how you control who can do what. You can get incredibly specific, giving users and services the exact permissions they need to do their job, and absolutely nothing more. And this is a super important distinction that interviewers love to ask about. A user is typically a person, and they have permanent credentials like a password and access keys. But what about your application on an EC2 server that needs to talk to S3? You never want to put permanent access keys on that server. No way. Instead, you use a role. The EC2 instance assumes the role, and it gets temporary, automatically rotated credentials. It is so much more secure. So if you take away just a few things about security, let it be these. First, the principle of least privilege. Always give the absolute minimum permissions needed. Second, use IAM roles for your applications, not users with permanent keys. Third, enable multi-factor authentication everywhere. Seriously, on every account. It's a game changer. And finally, log everything with CloudTrail. If something goes wrong, you have a perfect audit trail to see exactly what happened. And that's our journey. We went from the literal ground up, the physical regions and AZs, all the way through the compute, storage, networking, and security that brings an application to life. What you have now isn't just a list of services. It's a blueprint, a way of thinking that will help you build amazing, resilient, and secure things in the real world. I really hope this has been a valuable part of your interview preparation. Don't forget to subscribe to Suchar Next Gen Tech for more explainers that make these complex topics simple. Thank you for viewing this video.